Students, in this exercise, I am going to show you how to graph square root functions. So let's take a look. So let's say if you've never seen this parent function, which is a square root function, and this is your first time manipulating or working with this, right? Excuse me. Then it is always advisable to try and figure out what are the coordinates, okay, that you can plot by creating an XY chart. Now, I would not advise you, okay, to go with, these numbers here, because they're going to be very, very challenging to plot. So instead, I want you to think about, what are some strategic points that we can use. And in addition, then we are going to talk about something else, which is domain and range, which we have not talked about yet. So let's think about this, right? The x coordinates, okay? Can we substitute any negative values into a square root? And if you're thinking yes, because we can then end up with imaginary numbers, you're absolutely right. However, because our goal is to plot this on this Cartesian coordinate, and all of the points that are on this coordinate grid, they're real numbers. Because all the points on this coordinate grid are real numbers, we cannot represent imaginary numbers on this. Okay? So for that reason, okay, we're not going to consider any output, okay, that's going to be imaginary. So with that said, okay, what numbers can we substitute in? A, that will generate real numbers, and B, that we can plot, quote unquote, easily, right? So if you're thinking 0 is one of the numbers, you're absolutely right, because square root of 0 is 1. If you're thinking of 1, you're absolutely right, because square root of 1 is, I'm sorry, I got a little ahead of myself. Square root of 0 is not 1, square root of 0 is 0. What about square root of 1? Square root of 1 is 1. What about square root of 2? Well, I don't know what that is. That's hard. So you know what? I'm not going to do square root of 2. Square root of 3? No. Square root of 4. Square root of 4 is 2. What about my next one? 5, 6, 7, 8, 9 perhaps? Actually, the next one, the most convenient one would be 9. And why is that? Well, that's because this will generate another integer. So all the numbers between 4 and 9, they will not. They will generate numbers that are going to be irrational and very, very challenging to graph. So how is this square root parent function going to look? Well, it's going to look like this. 0, 1, and then at 4 it's 2, and then at 8 at 9 it's 3. So I'm off the grid, and that's okay. So it's going to look like this. So whenever we're graphing these square root functions, okay, understand that, again, the parent function is going to look like what we just accomplished here, and we're going to apply the transformation of the function just in the same format as we did before, right? So let's take a look at this guy right now. I have square root of x minus 2. Now, are we subtracting 2 from the overall parent function, or are we subtracting 2 from x? We're actually subtracting 2 from x, and if we're subtracting 2 from x, right, what kind of shift is that going to do? This is going to generate a shift in the horizontal direction. So this is going to be 2 units to the right. Remember, right, when we are subtracting a number, remember how we write the quadratic equation in vertex form? Well, as it turns out, we can write square root functions in vertex form as well, and that is, it's going to take on that form. So how is that going to look? Well, if I'm subtracting 2 from x, that means h is positive 2. That means all the points, okay, that was graphed in problem 1, they're all going to be moved 2 units to the right. So it's going to look like this. Let's take a look at the next one. Here I'm adding 3, so that means h in this case is it's negative 3. So the vertex in this case is going to be negative 3 comma 0. And again, it's going to be in the same direction. It's going to look like this. Let's see here, 2, 4, 6. Let's take a look at the next one. Square root of x plus 6 minus 4. Now, what's the vertex in this case? The vertex in this case is negative 6 comma negative 4. We're going to be shifting the square root function horizontally 6 units to the left and then vertically down, right, by 4 units. So my graph, my vertex will end up over here. And it's going to look like this. There's something else that I have not talked about yet, and that is what is the domain and range. So the domain, okay, of a function is simply, well, what are the values of x that we can throw in to evaluate the function? So the domain in this case, right, is, can we substitute in numbers that are negative? We can't. So all the numbers that we can substitute in will have to be greater than or equal to 0. Let's take a look at this guy. What's the domain in this case? Right? The graph here starts at 2. If I were to substitute in, let's say when x is equal to 1, is that going to be okay? It's actually not going to be okay, because square root of 1 minus 2 is square root of negative 1. So we can't do that. So what are the values of x that we can throw in and evaluate the function with? Well, that has to be x must be greater than or equal to 2. You see how the picture corresponds with what these values are, right? The graph starts at 0 in the x direction, that is, okay, and it just goes on forever. The graph here starts at 2 and it goes on forever. So you can think of the graph as that as well. Like, where does the, like, what's the beginning here, right? Or what values of x can we throw in and evaluate the function with? Well, it can only be all values of x greater than or equal to 2 here. What about in this case? The domain is x must be greater than or equal to negative 3. What about in this case? The domain, x must be greater than or equal to negative 6. So we talked about the domain, okay, which is just all the x values that we can throw into the function. What about the range then? So the range of values, okay, are all the y coordinates, okay, that can be generated as a result of this. So looking at this, okay, what's the lowest y coordinate that we see here? Well, the lowest y coordinate that I see here is 0. All the y coordinates are going to be above 0, equal to or above 0. Let's take a look at this guy. What are all the y coordinates here? So the vertex is located at 2, 0. So the range, again, we're talking about all the possible y coordinates, is going to be greater than or equal to 0 again. Let's take a look at the next guy. The vertex is located at negative 3, 0. So the range, again, is greater than or equal to 0. What about this? The range, this one's a little different. Where does the y coordinate begin? It starts at negative 4. So y is greater than or equal to negative 4. In this case, okay, negative 4 here, that's the starting point, okay? That is our minimum. That's the lowest point on the function. All right, let's take a look at some other examples. Okay, so let's do this one here. And actually, I'll make this positive. Whoops. Why is it not erasing? Apologies for this. Okay, and I'll make this, instead of +5, I'll make this -5. Okay, all right, so let's try this. Okay, what we're going to do is we're going to try to graph this out. So again, we're starting off with the same parent function. Okay, the same parent function. So the parent function is here. And just like all the process that we had studied, okay, with the parabola, with the absolute value function, right? What we're going to do is we are going to dilate this thing by a factor of 2 first, right? So so what we're doing here is we're multiplying all the y coordinates by 2. So what happens then? So that means all these coordinates, I want to do this in blue. So 0 is going to still be at 0. 1 will be at 2, and then 4, okay, we will be at 4, and at 9 we will be at 6. So this right now is just with the dilation, right? It's that vertical stretch. And then afterwards we are going to push all this stuff down by 5 units. So where will the resultant be? The resultant be, and I'm going to do this in bold, so the resultant will end up being at, we're going to shift all the points down by 5. All the points down by 5. All the points down by 5. And all the points down by 5. So we'll end up with the final graph looking like this. -3 radical x. Well, that's just, well, we just need to flip the parent function then, right? So the result is, at 1, it was at 1 before, so we're going to multiply that by -3, so we're going to be down here. At 4, it was at 2, so we're going to be down at -6. And then at 9, we're going to be at -9, so it's going to be like right here off the grid, right? So it's going to be like this. Let's take a look at another one. All right, so what we're going to do is we are going to take the parent function. We're going to blow this up, right? We're multiplying by a factor of 3. So start off at 0. At 1, we're going to be at 3. At 4, we're going to be at 6. Right? And at 9, we're going to be at 9. One more time. Why is that the case? Because the parent function was originally over here. Sorry for going a little too fast. So originally, in black, that's the parent function. We're multiplying all the points by 3 to get this graph. Next, we're going to be shifting this thing 5 units to the left because of this, right? +5. So we're shifting that 5 units to the left. So it's going to be here. And the last one is going to be over here. So this is going to be 5 units to the left. And finally, 5 units down. So our vertex is going to be located right here at -5. This point is going to be over here. This point is going to be at 1. This point is going to be not at 9, but at 4. So my final curve is going to look something like this in blue. So that's the graph.